My name is Stefan Mantoiu. I work at an environmental consultancy company, and I'm also a PhD student at the Institute of Speleology of the Romanian Academy. And I work mainly on bat migration and bat ecology in the eastern part of Romania, in the Dobrogea. Dobrogea has been subject to wind farm development in the last 5 or 6 years due to high wind speeds and low density of residents or locals. And they just kept on building, and right now we have even the largest wind farm in Europe that's onshore, something like 250 wind turbines. I'm going to show you a small study, a case study, a 1-year monitoring study of one wind farm, which is located in the northern part of the Dobrogea area. Okay, so the wind farm is composed of 20 Suzlon wind turbines. You can see their statistics there, 44-meter wind blades. Okay, so we did the carcass searches, we did the detection accuracy trials, scavenger monitoring, and ultrasound acoustics, and also roost searching and mistnets to try and see the bigger picture of the slide. And also, to collect the data, we used GIS techniques, mobile GIS techniques, including our own application, which is BAT Mobile. We have a poster on that, and I will invite you to talk to me more on that, because we want to do it at a European scale. Maybe we can use it together. Okay, so the carcass searches, we used a 2-week interval. I know it's long, but the problem with financing was at risk, and we chose this method. All of the wind turbines were searched. We randomly positioned for the detection accuracy trials. We used mus musculus carcasses, which are small rats, black, somewhat similar to bats. We planted them randomly in the site. We used RGIS to randomly mark that. Also, we had the red triangles are camera trail cameras. We wanted to monitor what is eating the bats, so you can see a lot of doggies are eating the bats. Actually, people are putting the dogs. If they don't want a dog, they'll put it next to at the edge of the town, and the dogs usually go where they can find food. So in this case, the wind farm. And we tried to move some, and they kept coming. So yeah. Okay. For the acoustic monitoring, we used only Peterson devices, but the one D500 and one D1000 for mobile and static surveys. And we had the static surveys was positioned on the ground and 1 month in the NASA wind farm. From our researches in mist netting, we found Lepus austriacus, Mitis dalbentoni, Huli and Natusi, a lot of episteros in the area, which are resident in loose cliffs. You can see them down. This was a surprise to us. I mean, there are thousands there. And yeah, it's another perspective. This is a general area of how the wind farm looks. And land use. You can see, for example, where it is in Romania, and the land use around it. The wind farms are positioned around the agricultural area, but not in the agricultural area, in the pastures. And the site is positioned, it has 2 components. One in the eastern, 16 turbines, and western, 4 turbines, and between 2 natural 2000 sites. A forest, a well-built forest with oak, and in the northern part, the loose cliffs with, which are in the Danube Delta reserve. So you can also see the number of bat fatalities that we have found. It's classified from 1 to 10. Okay, so this is a small 3D section of bat fatalities are red under the wind turbines, and with the small blue dots in the white is the mobile acoustic surveys. So you can see that the area between the lake and the forest is filled with blue dots. And also that there we had more than 60% of our mortality at only 4 wind turbines. So local spatial positioning from our point of view is essential to developing a wind farm. Okay, this just to see a bit more clearly in another perspective how abundant these are, the recordings are in the eastern part, and how low abundant is in this part. Okay. From NASA statistics, most of the mortalities, we found 49 carcasses. We can identify only 37 because some of them were partially scavenged. They were missing key components such as the skulls, and we had problems identifying by only, I don't know, some bone parts or skin parts or stuff. And we had mostly pipistrellus natusi. You can see here, Nyctalus noctala, Vespertilium moris, for example, appeared only in the late summer time frame. So instead Pipistrellus natusi, all of the pipistrelles were present around the year from April to November. We monitored from April to November. And these are bad fatalities. Okay, and this leads us to the assumption that Pipistrellus species could be resident, and Nyctalus and Vespertilio could be maybe local migrant or something like that. We just don't know yet for certain. And in the right we have an activity pattern of the static ultrasound transfer. You can see practically which was the most intense activity, somewhere between 9:30 and 10:30. We correlated this with the wind farm data, temperature and wind speed, and we had what all researchers had, negative correlation with wind farm, wind speed, and positive correlation with temperatures. I'm referring, of course, at the bad fatality, but crude mortality rates. We used a simple general estimator to calculate the total fatality, and it ruled out 4.75 baths per turbine per year. You can also see a small graph which represents the number of static monitoring recordings and the number of carcasses. It's not good to be like this in linear regression, but just the idea. I mean, somewhat it is correlating. We need much more data. This is done kind of monthly. Somewhat, I don't know, it shapes the activity in the static acoustic mountain. Okay, so we did a small model, Markov model, to see where bats, we isolated feeding areas from the recordings, and then we split them by the topographic position index, which shows us, for example, where are ridges, where are valleys, and here you can see these classified, and you can see that turbines that were closer to valleys, closer to steep valleys, had more impact in the feeding areas that we identified. Okay, so we found that there are, for example, in situations when we didn't have any carcasses on the ground, we found significant difference between this and situations regarding the environmental variables, and situations where we found one or more than 2 carcasses on the ground. So practically, as a mitigation measure, you can propose to the wind farms to shut down their wind farms when winds are lower than 5 meters per second, and you exceed the daily average temperature of 25 degrees Celsius. This is very important because it could cut back a lot. I read that people did this, and it's more than 60% of the mortality fell. Okay. And they actually calculated how much they will lose, and it will be 0.05% of their productivity, and they are willing to do this for now. Okay, so we actually have another year of monitoring. We started the second year of the monitoring. And we are doing this weekly now. We had a 50-meter search area. Now we have 100 meters or more. Even sometimes we search 150 meters. We would like to, we collect samples, hair samples, and we would like to see if we can do stable isotope analysis on their fur and see if they're local or long-range migrants in the area if the wind farm affects them. Okay, so I'd like to thank my colleagues who helped me in this, and thank you. If there are any questions?
Thank you, Dr. Stefan. One question, please.
You wrote the second last slide, 35% of all contacts were made between 21:30 and 22:30. What is that relative to sunset?
Sorry, relative to sunset?
Yes, how long after sunset was this?
Yeah, I mean, it is after sunset. I know 1 hour or something like that, 1 hour and a half. So
it's after the twilight?
Yeah, we actually set the detectors to record half an hour before the twilight and before the sunset and half an hour after the sunset. So yeah, it's after. Always 21:30 in Romania is always after the sunset.
One more question. No. I have a question. So, in the list of species, you didn't mention the Schreber's bat. Isn't the Schreber's bat, Myopterus, isn't it in the area?
I know that Romania is considered the land of the Myopterus, but unfortunately, on the northern part of Dobrogea, there are not yet recorded large colonies of Myopterus Schreber's. Yeah, I think, in a matter of fact, I don't have any recording on ultrasounds because we also do large transects on the Danube or whatever. And we didn't find Myopterus Schreber's. There are large colonies on the border with Bulgaria. And they are migrating to Bulgaria and back to Romania, but for now, in the northern part of the Dobrogea area, no.
Okay, thank you. One question, yes? Who? The back. Okay. Microphone.
You said estimated 47 casualties per turbine a year.
No, 47, 4.7.
4.7. Okay.
So, 47 was a large number.
If you don't put it in place, how long can the local bat population be sustained in the area?
For example, that's a good idea. For example, we had a large colony of, we estimated over 1,000 Pipistrellus natusi combined with Pipistrellus uli, maybe Vespertilium minors there, we don't know exactly for sure the last. And for now, for instance, this year that colony disappeared. Yeah, so I don't know if it just moved or, you know, it's, you have to study, 3 or 4 years, maybe more, to get a general idea of this. And we need data. We hope that we will be able to monitor this for such a long period.
Okay, thank you, Dr. Stefan. And thank you all the speakers of this